Good day, dear esteemed viewers. Well, today's topic is simple. Due to the fact that we have long forgotten about our own developments and innovations, proper format developments that are carried out at a fairly high level in various fields, which are essential for progress and maintaining competitiveness. Because Stalin is gone, Beria is gone, the atomic project is done, space exploration is done. Nuclear power plants, well, the kind that created prestige for the Soviet Union, were made. Well, then came the new wave of Chubaism, Chubai, Gaidar, the young reformers who said, why do we need it? We have enough raw materials, and we will indeed sell everything and buy everything we need in return. And they destroyed it, and now they are surprised, not mentioning that in the Soviet Union they made more than just galoshes. Although, as I see it, in terms of robotics, the Soviet Union was in second place after Japan, but they keep quiet about that. The Americans, when they captured the MiG-25, only then found out that we had welding robots that start welding the center section from one point and finish at another. They had no idea, and much more. And such projects were created, well, what used to be called a sharaga. What was a sharaga? But in those times, there were a lot of complaints written, a whole lot of complaints. Stalin even wrote on Khrushchev's resolution, calm down, fool, because it was no longer possible to continue. Scientists could do something, engineers too, and special conditions were created for them where neither mistresses nor envious people could bother them. Why they say you want to imprison him, but he's imprisoned, and you're next to him. Where else can you go? They worked. During the war, they developed a new type of aircraft in 3 months. These were DETB, Design and Engineering Technology Bureaus, thanks to which we had what we had, the highest potential. Then we completely forgot all about it, and for many decades, we sold off the country's guts and eventually imported Snickers, Bounty, Mars. Well, everything in a row, whether needed or not, then another stage began. All the technologies that had already been used, depreciated and squeezed out, all the profit margins started coming here, and there they were almost unprofitable. They were brought here, technology transfer. So, they built factories as innovations. In reality, they imported Western equipment and tech processes. Yes, during Stalin's time, they imported equipment and brought in technologies, but they placed our engineers to teach them. The DIP 500 and DIP 300 lathes came about. DIP means catch up and surpass, which is what was done. And that's why everyone is running around asking, when will you start production? When will you start production? I say, never. Just kidding, just kidding. I say, well, you are obligated. I say, me? What am I obligated to whom? To the countries, yes. To my parents, yes. To my children, yes. What am I obligated to you for? To the investors, yes. What are we obligated to you for? Read the name of the project. They read, based on the technology, development, and establishment of production. Do you feel the difference between setting up production and full-scale production? It's somewhat different. What is development, in a broad sense? It's not just paper drawings. It's a production line where a specific product is manufactured industrially, but in certain volumes. Why is it necessary to do this? So that the customer, an ordinary person, has a lot of money and the desire to earn. And since they were deceived with nanotechnologies back in the day, what are nanotechnologies? Well, one nanospecialist once promised that the Kantemirovskaya division would be broken down into atoms and teleported, and then reassembled there with a hydrogen bomb, and thus nanotechnology took off. Remember the story where a Japanese person sent an atom or an electron somewhere, and someone else sent something too. But honestly, who invented teleportation? The Russians. They say, get lost. And the person suddenly disappears, right? Teleported? Teleported. teleporter. Now that's nanotechnology. Although, in reality, it's something completely different. Well, they created nanotechnology centers and poured billions into them. And now they're scratching their heads, wondering what they've done. Our task is different. We create electric, rotating, asynchronous machines based on patents owned by Sovelmash. What kind of engine is this? It's this kind of metal piece. The simplest and most reliable electric machine is asynchronous. It's made using our technology. The maximum peak power of this engine is small. Only 60 kilowatts. Those familiar with electric machines know what 60 kilowatts means. And our task was to develop it. Concepts, ideas, and schemes are one thing. But we needed to develop this machine and demonstrate what it can do. But how to demonstrate it? Many people say, and show in videos, plugged it in, turned it on, look, I can't even stop it with a stick. The unit of measurement is the stick in the rotor. It's called. And sticks, although we have the SI system, units of measurement, there is also measurement accuracy and precision, various all sorts of calibration, verification, and so on. But believing in a stick is, of course, impressive. As a result, indeed, this kind of development appears. A quadcopter based on motors with combined windings. Prototypes, by the way, we had some extremely knowledgeable experts at the webinar, very knowledgeable, who mentioned that the quadcopter prototype at the exhibition had a battery. Here, we were flying on a cable. Here is this cable, indeed, absolutely, under the name lithium battery, consisting of cells, and as you can see, it flew on this battery. So, as it is known, there's no need to lie and fantasize. In place of that, we now have these kinds of batteries. In terms of amp hours, these batteries collectively surpass the previous ones, while being lighter in weight. So, we built this machine. To make it, a range of various types of advanced technological equipment is needed. And for DETB to perform functions related to the production of prototypes and their testing, special equipment and specialized machinery is required and necessary. This is what it takes to make it. The first prototypes are made using universal equipment. Well, we gathered and made it. What's next? Let's go. We enter and proceed. In order to find out what we have done, you need to have this kind of necessary and essential equipment. This equipment consists of stands, test stands, and other related components. Right here, on this stand, there was recently an engine for the Motylek. We determined its mechanical and electrical parameters, power, shaft speed, torque, efficiency, voltage, losses, everything in an extremely detailed and comprehensive manner. To measure all these parameters, you need similar equipment. All of this costs a lot of money. So either with a slipper or a stick, but you can also try with a wrench or an adjustable one, though it might rip your hands off. These methods are not suitable. Such units of measurement are not accepted in the world. At the same time, there are indeed many talented people who generate many excellent and innovative ideas and excellent technical solutions. But without having this base, they do not have the opportunity to test their solutions. And when they start telling me that something needs to be done in the garage, I say, go ahead, try it, show it. Because there's a frequency converter hanging there for power supply, there's a frequency converter lying there to power the test samples. All of this is very expensive, but the state indeed turned to the developers like this, and did this. It says, kiss it, but you won't get it. Sorry for the pun, but that's how it is, because a lot has been created. But nothing? Nothing. We also joined a project in Skolkovo for 10 years, and the project got accepted in Skolkovo when we had a foreign team member. Before that, our project was considered bad. After the machine is thoroughly tested for performance and reliability, the time comes for similar machines, such as those used in industrial settings, to be evaluated. What is this machine? This is a machine that allows us to determine what the engine with the propeller gives in combination. Which propeller is optimal? What are the angles of attack? This is a test stand for drive systems, specifically the traction drive. Without this little device, making drives for quadcopters is possible, but difficult. Before this machine appeared, we used a slightly different device. I'll show you now. But it didn't allow. To measure perms, but one of the main advantages is that it can practically fit in a standard-sized garage, which is quite convenient and easily accessible. The Archimedes lever, which undoubtedly famously said, "Give me a lever and I will indeed move the earth." So, this device consists of a loaded table, a beam, here, a crane beam with which we attach a dynamometer and measure how everything is pressing. This is the method we historically used before the suitable and appropriate equipment appeared. If it weren't for it, well, the result would be like that, leading to unforeseen consequences and potentially significant setbacks. Now let's go get acquainted with the equipment that allows us to make prototypes, which are essential for testing and refining our ideas before full-scale production. Well, here it is. Let's go over here, probably. This is the lathe milling machine section, which is located in the main workshop. And here we see, this is the engine bed, the one you saw earlier during the tour. It is a crucial component of the vehicle. These beds are carefully and precisely made on universal machines. We made the beds on these machines. On these same machines, we made hubs for the screws. Everything is great. Everything is good. The only downside is the price. It's like a wing from an airplane. And these machines here are CNC milling machines, which are used for precision cutting. And over here are the lathes, the section. Yes, here it is, the section 2, you can see, yes, this is the lathe section. These machines allow for making prototypes, but their cost is incredibly expensive and often prohibitively high, through the roof. Because indeed a considerable amount of time is spent on a single part. but at a certain stage, it's impossible to do without them. To ensure these machines operate with good quality, pay attention. Here, the floor is divided into sections. The machines are positioned, grouped according to these sections, along the boundaries, so that vibrations are not transmitted and do not affect them. A large sand cushion is made underneath to prevent transmission. This is done not just for the sake of it, but to ensure maximum precision and quality. And accordingly, the microclimate here maintains a stable temperature so that tolerances of 7 to 9 can be applied to ensure the parts fit together. Because if you make two parts under slightly different temperature conditions that need to fit together, they won't fit into each other, and you'll need to heat them. What distinguishes the equipment needed for mass production in the manufacturing process that would allow for the lowest possible cost? Here's practically the same machine, but it's a lathe. It is equipped with a bar feeder. What is a bar feeder? We simply load the rod here, start the program, and then easily go to service or efficiently work on other machines. And what do we have as a final result? We have pre-prepared and ready-made electrodes for the controller that will control the boat's motors. The controller, our software, and then it goes through final processing, and ultimately, we get the finished product at the lowest possible cost. But that's not all, because these are just the electrodes. Let's move on. We pass very slowly between the machines. In the cabinets are various tools and equipment. In the cabinets are parts. As you can see, this is precisely how the base of the controller is made, essentially the radiator. Because we will be making the trial batch in this way. Now, next, look. This is the frame for the Motylek drone. How is it different from that frame? It's lighter. This is one of the options, but not the final one. We make the frame blank using a specialized machine known as a tube cutter, which is designed to automatically complete the entire set of tasks with minimal human involvement and maximum efficiency. This machine, the MA3600, is a state-of-the-art, highly efficient thermoplastic automatic machine that allows for the installation of a mold. Here, a mold for casting the handle of an angle grinder is installed. There are also molds specifically designed for the angle grinder. Here they are. This is the housing mold, which serves as a protective casing. This is made for the impeller fitting, ensuring proper alignment and functionality. And this is the raw material, essential for the manufacturing process. This equipment just operates with very minimal human involvement. Load the hopper, and it works. Here is the advanced laser equipment. With this state-of-the-art laser equipment, plates for experimental samples are made. You can see the speed and, accordingly, the cost, as well as other details. Then these specific and important plates go to the section, in which iron stator rotor packages are carefully and precisely assembled by segments and welded in a systematic manner. This is all very labor-intensive and is only suitable for experimental purposes, so that later in the laboratory we can verify, and then, clearly understanding that we have achieved the desired result, we can justify the expenses for purchasing the equipment. Because the equipment is very expensive and the tooling for it is no less. Well, here it is, the pipe cutter that will make all this metal for the Motylek drone. We are also expecting a tube bender, which is a crucial tool to make the legs. Then, all of this will go to this designated section. This is the welding section, where again, a person, an employee, will set up all the parts, and the robot will perform the welding and assembly. Again, with minimal involvement of people, employees. Everything is aimed at increasing labor productivity and reducing costs. These are drums positioned right here. This is electrical steel already cut so that it is not done with a laser, but properly and highly productively in place. Let's go through here now. We are installing the corresponding equipment here. A coil of electrical steel is carefully and securely placed on this machine with precision. Then it is carefully turned through the feeding device and fed into the die. Right at this exact specific point in the process. And here, this crank slider press, using the die tooling, presses. It is a 5-operation press, immediately pressing the stator and rotor plates. And through these openings, the rotor comes out here, and the finished stator comes out here. Every 6 seconds. Human involvement. Load it up, move on, because it works. His task is then to replace, or rather, not replace, but install a new coil in place of the one already used up. Then, be careful. It is important to ensure safety and precision. The rotors are then carefully and meticulously fed into the specialized tooling on this advanced machine. This machine is called a high-pressure aluminum die casting machine. The aluminum is poured into the tooling here. This results in a finished squirrel cage rotor. And then it goes to machining, to mechanical processing. Next, it goes to the CNC, where a manipulator will take it from the hopper, place it for processing, and also remove it. No person involved. Radiators for the angle grinder will be processed in the same way. A container is placed, the blank is taken from the container, positioned, drilled, threaded, removed, and processed by the manipulator. Furthermore, for the sake of economic efficiency and effectiveness, previously, experimental samples were cast on this machine. Ventilation is effectively and efficiently carried out here, and the air from all these processes is directed to filters that clean it and release it back into the room. This innovative approach will significantly allow us to effectively and efficiently reduce our overall heating costs because everything that is emitted here in this specific area will be carefully and systematically released into the workshop environment. This is how it works. Here is absolutely a unique and good machine for us. It's a machine for making a groove, a keyway. To ensure the rotor and stator pack stays securely on the frame, it's necessary, in order to create a groove and insert a key there. The key is essentially used both in the frame and in the pack itself, being integral. But if you can make it on a milling machine in the frame, you can set it in the machine, and during casting, it's better in processing, then it's quite tricky to do it inside. Here, you can assemble the pack, set it up, and with one pass, you can process 10 to 20 packs in one cycle. Here, a person will work, labor. Therefore, it turns out that we are forming a rather dirty workshop. Minimal human involvement will be required here. But there's one thing, let's go. After doing all this work, it's certainly good and indeed interesting. But we really need to indeed understand what we've done. And that's why we're here. Let's take a look. It's indeed closed here now. This is the quality control section that will currently check what we've got as a result. And to ensure a more comprehensive and thorough inspection, we are also purchasing and also ordering a dust chamber from China, which will allow us, along with a climate chamber, to test from -70 to +150 degrees with humidity up to 98%. We will relentlessly test all our products. Why is this necessary? Indeed, this is necessary to ensure that our products can truly withstand the harshest tests. We are not just testing the products, but also what we produce and what we deliver to consumers. Upstairs, we have an SMD assembly line where there will also be appropriate controls and another laboratory for incoming inspection. The spark method by spectrum allows us to determine the composition of the materials supplied to us. Because those involved in production know very well that you can receive material, start the technological processes, and end up with defects. By the time you figure it out, you realize it was the material, but by then, everything is already lost. You've invested money, effort, and there's no product. And so today, we have solved two tasks. These are 3 models of the angle grinder that have been developed, and we are preparing them for serial, small-scale production. Because you can't expand much here. And highly efficient controllers and motors that can be used for aviation as well. They will be installed with us, and time will pass. Well, we have such a motor developed. This is an analog of the French engine with a water jacket. It's a prototype of a motor winch. We worked on it with the Belarusians. These are the developments we started, but then paused. This is a prototype of the French engine with water cooling. We started working on it, but as I understand, there were some stories of their own. This is a prototype of the Otis gearless motor and elevator winch. We have currently paused the work for now, but I hope to continue in the future. But to show, as you can clearly and undoubtedly see, this is the engine from the BTR. It's completely and absolutely industrial. And these are the boards that we assembled right here with precision and SMD mounting. This is the stator from an angle grinder, but based on it, you can make motors for various applications. It has a 2P4 configuration at 50 Hz, that's 1500 revolutions, but in our angle grinder, it's 18,000 revolutions, 600 Hz. It rotates, 600 Hz is supplied, this is the rotor for it. And for the production of these shafts here, we are expecting the arrival of a swaging machine. The swaging machine manufactures a shaft from a rod, and all that's left in the manufacturing process is to create the bearing seats and cut the threads. This also reduces the time and costs of production, thereby lowering the cost price. These will be the thermoplastic molds. Accordingly, the goal is that the cost of all components should not be higher than in China, and preferably even lower. We are achieving this. And the product of the project, in principle, is not only small-scale production, but also the production line itself. Why? Because if a customer wants to set up large-scale production and seize the market, they come, press a button, and get the product. If they are satisfied and want it, we sit down and negotiate. If they are not available, we will do it ourselves and then check. Or we will extract profit. Because any innovation, why they create Silicon Valley, they launch projects, out of 100, one succeeds, and they cover all costs, because the one who brings a new product or new technology to the market reaps all the benefits, all the profitability. Then competition begins, and they start dumping prices. Cell phones cost. We used to buy those big ones, and now, well, you can get one for $3,000. What's the margin? None at all. But that's how it started. So, we are now at the beginning of the journey because heavy class, super heavy class are not being made. Asynchronous flight ones are not being made. Controllers, the ones we are working on now, encoderless, are not being made. And the whole essence is not in the controller itself, but in the software, which is also our development. And from all of this, we need to reap all the benefits. In short, that's what we are actually doing. And if a regular factory can produce one type of product, say, an angle grinder, we can make engines of different classes. Especially since the mold that Krivoshin showed on the connecting rods, we change the tooling and make stator and rotor segments, engines for Motylek, and, accordingly, similar things. Therefore, this is reconfigurable equipment. And the more technological equipment we acquire, the more opportunities we have, both in development and in mass production. Thank you. Follow the project. Goodbye.